A clock has a seconds hand that is 10 centimeters long. In 1 second, the seconds hand rotates 6 degrees. How far does the end of the second hand travel? In this problem, what we're looking at is, here's our seconds hand. It's going to travel in 1 second. It's going to travel like this along the outside edge of the clock. If we're trying to figure out how far the end of the second hand has to travel, what we're interested in finding is essentially the arc length, that curved distance. We have a formula for the arc length. The formula is S is equal to R times theta, where S is the arc length, R is the radius, and theta is the angle measurement in radians. In this particular problem, we aren't given the measurement in radians, but we are given it in degrees. So the first thing that we have to do is we need to convert 6 degrees into radians. So we'll use the same process that we've used with previous problems. If degrees is on the top, we need to put degrees on the bottom, and we want to change into radians. And we can use the fact that there are 180 degrees and pi radians are equivalent. So doing a little bit of reducing here, let's see what happens. The degrees cancel, leave us with the radians that we want. 6 goes into both the top and the bottom, leaves us with 30 down below, and we end up with pi over 30 radians. So that is the angle measurement that gets traveled. Now, what we want to find is the arc length. So we go back to the arc length formula. S is equal to R is the radius, which would be the entire length of the seconds hand, which would be 10 centimeters. And we're going to multiply that by theta, which is our pi over 30 radians. And when we multiply that out, notice we can do a little bit of reducing here, and we can end up with our solution of pi over 3 centimeters will be the distance of the arc length that's traveled along there. If pi over 3 isn't very meaningful for you, you can go ahead and take the pi value and divide it by 3 on your calculator and get an approximation, which is just over 1 centimeter, about 1.05. Either of those answers are great, and you're done.